Hello everyone, in this video I'm going to discuss the example for optimization problems. A garden center wishes to use the fencing to enclose three equal-sized rectangular plots next to each other. As shown in the diagram, the total area of the three plots is to be 288 meters square. Find the expression for the total area in meters square and the total length in meter of fencing required in terms of x and y. B. Express L in terms of x and y. C. Hence, find the dimension of each rectangular plot. So if the total length of the fencing is to be kept as low as possible, D. What is the minimum length of the fencing required? So here we have the X, and here we have the Y. So let's focus on the area. As we all know, we have 1, 2, and 3. So meaning that, number 1, we have XY, plus with the second one, we also have the XY, plus with the third one, we also have the XY. So area will be 3XY. As for the L, for the length, so notice that we have 1, 2, 3, 4, 5, and 6. So here we have the 6X. Plus, we have 1Y, 2Y, 3Y, and 4Y. So we have 4Y. So that is the answer for A. B. Express L in terms of X only. So meaning that we have to substitute 288 over the 3X, which is equals to Y. So Y will be equals to 96 over the X. So kindly substitute. So L is equals to 6X plus with the 4 bracket 96 over the X. So we have the 6X plus 384 over the X. That would be the L. So that is the answer for B. Express L in terms of X only. C. Find the dimension of the rectangular plot if the total length of the fencing is to be kept as low as possible. So number 1 is to find, we have the L, which is equals to 6X plus we have the 384 over the X. dl dx, where we have 6 minus 384 over the X square. Second derivative, so we have the positive 768 over the X cubed. So that is the second derivative. Continue. Find the critical. So we have the dl dx, which is equals to 0. So 6x squared, which is equals to 384. So x squared is equals to 384 divided by 6. Then we have the 64. So x is equals to positive 8. X is equals to negative 8. Next, we have to test the value. So if the x is equals to 8, if the x is equals to negative 8. So if the value x is equals to 8, then the second derivative will be equals to 3 over 2. Then if the x is negative 8, then the second derivative will be negative 3 over 2, where we have less than 0 is a maximum, greater than 0 is a minimum. So refers to the question as low as possible. So we prefer x is equals to 8 so that the length of the fencing is to be kept as low as possible. Continue, we have the D. What is the minimum length of the fencing required? So if here we have the x, which is equals to 8. So we have to find the value of y. So it refers to the situation in here. If the x is equals to 8, so we have y, which is equals to 96 over the 8. So the value of y will be equals to 12. So that is the minimum dimension. Continue. Total length. So we have L, which is equals to 6 multiplied with the 8 plus with the 4y. Then we have the 48 plus with the 48. So the total length will be equals to 96 meter. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.